right, I'll try to make it very quick. So this is another framework. So I had to develop it because we had this use case where we had to discover, let's say, the entire, let's say, topology discovery, layer 2 topology discovery using CDP or LLDP protocol because of some requirement in the use case, right? So what this is okay, before I move on, so I'm gonna, these are the agenda. So I'm gonna cover what this is, what are the uses, the architecture, and there are some callbacks, and I'm gonna walk you through how do we code our use cases in these callbacks, right? Some quick development steps, and then how do we execute the batch operations, and then the demo. All right, so what is it? It is basically a framework. What you do is you have like you execute a specific code for n items in a batch size of x. So for example, a use case could be, let's say, in an environment where you have 10,000 devices, and then you upgraded the net, and then you have to migrate the net of those 10,000 devices to a new target net. How would you do it? You cannot sit around do it one by one, or if you write a custom script outside NSO, that might work, but you lose, you have to do a lot of custom logging and such. Or if you write an action, NSO action, it will lead to a timeout, right? So the framework essentially what it does is like it says, executes a user code for n items in the batches of size x, right? So the batch size is user defined, or it can be programmatically identified depending on your requirement, how complicated your use case is. And now, because of this, the developer focuses solely on that small portion of the code execution, not the entire network-wide, right? Again, plug and play, and this is a subscriber, and it's a subscriber-based package. You don't have to worry about anything. You just say, okay, make the package, and it's generated for you, and then you code your stuff. Another thing is calendaring. Meaning, say, for example, if you want to run some code only during, say, midnight to say 6 a.m. in the morning, you can instruct this in this framework. You can just say, okay, this is the execution window, and you can execute it. Okay, some of the features, but not limited to. Again, application-specific user-defined inputs, meaning you might have a use case, and you can define your own custom inputs depending on the requirement. And for the batch execution, the logs are stored automatically. And so out of those n items, there will be some, let's say, items which will be successful and which will lead to a failure. So all of those will be recorded. And let's say, for example, in the course of execution, let's say you might want to terminate the execution for the rest of the pending items. Even that can be done in case if there's any issues. And the concept of global lock. For example, there might be multiple use cases that you have coded, and for you to execute that, it requires a global lock. Let's take an example of a ned-migrate, let's say, use case. So there might be some services which you provision, and let's say, for example, on a specific net version, right? But then if you are, let's say, migrating it, you can say that acquire this global lock and then avoid any other code executions. And for any failed items, you can retry the failures only for those. And like I said, including a package generator to generate this package. All right, so where can this be used? This can be used in network-wide topology discovery. When I say topology discovery, I'm referring to the layer 2, like I said earlier. Or it could be any service inventory discovery, again, network-wide, ned-migrate, and okay, and another example is this reconciliation code execution with no networking flag, which is what I'm going to demonstrate in a while. Okay, architecture. How does it work? So I said it's an NSS subscriber based. So for example, a user, let's say it starts with an incoming request from a user, right? And this is basically, the user then triggers this code execution. What happens now is the code, so in this callback function, we are identifying the list of target items, right, using this get input callback. Once this is identified, it returns this n items, and then it writes into this list called pending items. This is where there will be a listener listening to incoming changes. When there's a change happening in this list, now what it does is it gets the first X items, which is depending on the batch size, right? And then it writes into another list called batch request list. And there will be, again, another listener, which then triggers the user code execution using these X items out of those N, right? And then this is where we write our custom code. Think of this like a CB create that you have in a service point, service callback function, right? And what should the expected return items are the successful items, the failure items, and the log. And then the batch execution framework will automatically log it to this list. And the whole cycle repeats by updating these pending items until all these items are executed. All right, so different callbacks. So this is the first one that I just mentioned. So this is where this is again the class implementation. So you have this get input items, and again, this input is basically going to be your Yang input, which I'll be showing later. This is optional. You expect to use, some of the inputs that you provided and return a total of n items, right? It could be anything. It could be devices or any network attributes. Again, the execution will end when all the target items are processed. Okay, second one is the get batch items. So by default, the batch execution framework, it does a first X FIFO, right? First in, first out. But if you want to override that behavior, this is where you can do that. And I'm not going to go into the detail of why you would need it. This might be required, and I've seen the need for it, and hence this has been implemented. All right, and this is where finally where we write our custom code. See, the items that you see here, this is basically the small number of, let's say, the X items, which is broken down from the N items, right? And this is the list, the original input that we model in the Yang. And the expected return types it's a tuple of successful items, failure items, and logs. By returning this, the batch execution framework automatically stores all this detail in the CDB. All right, how do you go on about developing this? So the first method is by generating a new package. How? You can run this command called be make package and then -g, and which will then prompt you to enter these details, the package name and the description. This will be used to generate Yang and also update the package metadata. And this is how it looks like. So the one on the right side top, this is the back end, right, where all the intelligence reside. This is your custom code, depending on your requirement. Method 2 might be augmenting to an existing NSO package. For example, if I have this, the earlier example that I was showing, simple L3 VPN service. If I wanted to do a batch reconciliation of the L3 VPN service without creating a separate package, what I'll do is I'll say augment using the -a flag, and then this is what I provide, batch L3 inventory discovery, and it gets merged into this folder, right? Okay, and this is the Yang model which is generated. These are all groupings, and this is where you write your custom inputs. right? Okay, there are different, how do you um, execute or trigger the operations is basically using an action. You can say you can do, execute, terminate, retry failures, redeploy, right? And then I'll move on to the demo. Nick. All right. So I'm just gonna walk through the code. I already have prepared the earlier example when I was showing the L3 VPN service reconciliation. I did it only for one device manually. Now I'm gonna plug the batch execution and do it for all the iOS XR devices, which is where my service resides. So I'm just gonna show real quick what my inputs are for this use case. So if you see here on the screen, line number 28, so I just have one flag called reconcile true or false, meaning by default, I will do a commit with no networking, right? If I include, say, reconcile true, then it will try to reconcile the service. And it will look for all the devices. Right now, if you see, in the inputs, I don't have the list of devices because I expect my code to identify those lists of devices dynamically, which is the n number of items, all right? So yeah, if you see here, the get input items, this is where I say get the target XR devices, returning back to the framework. I have excluded that get batch items because that's optional. You don't have to implement it. So I have this execute batch, which calls that MBR action that I showed earlier, and it accepts this list of devices, reconcile whether this is true or false. And then, yeah, I'm not going to go into the details of this. Again, just the code implementation of what I did earlier. So it's going to like first call with no networking flag, and then it will, if the reconcile flag is set, then we're going to do a redeploy reconcile, right? That's all it does. So how does GUI looks like is, so let me just zoom in a little bit. Okay, so this is the module, right? So everything is getting augmented to this use case. You see here, I have something called as batch service discovery. This is what I call it when I generated the package. And I can say, so this says this is augmented, and hence all this list, these are all standard. So for example, when I click on plus, this is my specific request ID. Let's say L3 discovery. Now, these are some of the things which is automatically generated. So I'm going to say batch size is 1, and it will store. This is basically where you have your execution status, global lock acquired, required, true or false, last updated. This is just the timestamp. Yeah, pending items. This is basically what the framework will automatically update depending on the number of batch items, right? And this is the small batch request. In this case, it's going to break it down into, let's say, per device. And this is the custom inputs, reconcile true or false. So if I say, I'll set it to true. And this is what I meant by calendaring. If you want to like execute this code in a specific window, you can specify it, the start time, end time, and you also have the different days that you could execute it. Every day, Monday, Tuesday, till Sunday, right? All right, so this just serves as an intent, right? When I commit, the request is just stored. It doesn't execute. Now, how do I execute this? I'll go back to this request. Sorry. And then this is an action. And this is where you specify all the different actions. If I say execute, let me just go back to the CLI. Okay. So let's see what's happening here. I'll just show you the configuration commit list. Here you can track what's happening, right? So the first thing that happened is it created a batch request. If you see here, it automatically does it. It uses the main ID, and it suffixes this end batch. So if I do again, you see it has, so in the backend it does a sync from and all the stuff. If you see here, all the batches are completed. Now let's see how the logs look like. If you see here, this has created smaller batches of the request. I'll click on this, the first one, and here you will see that these are the logs. And this is what I've coded in my batch execution callback, right? How do I want to store those logs? I decided to do it in a dictionary because it's going to be easier for me to just parse it. If I can just augment another action to read this and then generate a CSV report. If I have to do like a network-wide discovery, and if something failed, I can find out why it failed, right? So now, if I go back here, show running configuration service, a simple L3 service. So right here, right now, if you see, it has reconciled both the devices. I have only 2 devices in my environment, so this has reconciled all of them. So now, how do you know if it's reconciled successfully or not? I'll just try to do, let's say no simple L3 VPN service, commit dry run out from it native. It should attempt to remove from both the devices. And that's it. Any questions? All right. That's it.
If that was all the sessions for today.
Yeah.
Thank you, Lenin.
Thank you.